Welcome to the workshop. Today we want to take a look at some directed graphs. For our example, we want to consider this graph, and we'll answer just a few questions. So first, a quick reminder, a directed graph is just a graph in which each edge is given a direction. Now that direction is assigned in the edge set by considering each edge instead of as a subset, a two-element subset of the vertices, rather it is an ordered pair of elements from the set of vertices. So for our first question, we want to give the set of vertices and the set of edges. Of course, we want to use appropriate notation when we're doing this as well. So for the vertex set, typically that's denoted with a V. And we also want to use set notation. So the set of vertices are simply A, B, C, D, and E. Okay, excellent. A, B, C, D, and E. All right, that seems pretty straightforward. Now the next thing we want to take a look at is the edge set. Now that's denoted by E, and again, it is a set, so we should use set notation. But in this case, since we're looking at directed edges, we're looking at ordered pairs. So each edge would be given by an ordered pair instead of a two-element subset. So to help make sure that I've labeled each of these or identified each of the edges and each of the edges only once, I'm going to list them by looking at the edges that go away from each vertex. So A, the edge that goes away from edge, for A, the edge that goes away from A is going from A to B. So we have edge A, comma, B, because it goes from A to B. Again, ordered pair. This other edge I'm not going to worry about for now. That I will take a look at when I look at vertex E. For vertex B, I have B goes to D and B goes to E. Again, the directed edges, B to D and B to E. So I have B to D and B to E. Excellent. The other two edges I'll consider with the other vertices. This one I already looked at. This one will actually be next. So at C, there's only one edge that goes away from C. C goes to B. Excellent. So those are all the edges that go away from C. At D, we have D goes to C and D goes to E. And then finally we have at E, E goes to A. So that gives us our vertex set and our edge set, where the edges are directed. Again, directed edges. Directed edges are given by ordered pairs instead of two-element subsets. Excellent. Next, we want to list the other vertices on the directed edges to B and determine the indegree of B. So the indegree is the degree associated to the edges coming to B. So here's B, and we look at the edges that are going to B. That gives us the indegree. How many there are gives us the indegree. So we have A goes to B and C goes to B. So A and C are the vertices, the other vertices on the directed edges to B. Directed edges to B, the other vertices. And the indegree of B is 2, because there are two edges that go to B. All right, next we want to list the other vertices on the directed edges from D. So now we're looking at the edges that go away from D and determine the outdegree of D. Now that, of course, is just the number of edges that go away from D. So D, here at the bottom corner, we have D goes to C and D goes to E. So there are two edges that go away from vertex D, and those edges go to C and E. So C and E are the other vertices on the directed edges directed edge, D and C, D and E. And that gives us the outdegree of D is 2. Now, we could also talk about the outdegree of B, and there's 1, 2 edges going away from B, so the outdegree of B is also 2. And the indegree of D would be 1, because there's only one edge that goes to D. Excellent. So that's just a basic example of a directed graph and some of the characteristics. Its definition, and indegree and outdegree. Excellent. We'll have more examples up shortly. In the meantime, have a great day, and I'll see you guys again soon.